have this little problem about the turtle, the rabbit, and the alligator that at first I did not think was going to be very challenging, but it turned out to be rather difficult. So I'm going to start with the rabbit as they're all racing, and the first information they give us is the rabbit took off sprinting and just kept getting faster, starting at a rate of 1 meter per second and going 1 meter per second faster each second of the race. So I made a little a spreadsheet, and basically you can see right here as the time goes up, the speed also goes up. So he started at 0, distance 0 speed. The next second, his speed was 1 meter per second, so that means he went 1 meter. The next second, his speed was 2 meters per second, so we went 2 meters in addition to the 1 he had already gone. And this keeps going, and you can see the differences here as it goes up. Also, one note on the rabbit as I was looking at it, I noticed that his distance, yes, was changing by 1, and then 2, and then 3, and then 4, but that his change in his change was increasing by 1 each time. So when you have a constant change of the change, I know that that is a quadratic. So I had that in mind as I was doing this. And with the rabbit, I noticed that he crossed the finish line somewhere between 13 and 14 seconds. So then next, it talked about the turtle. And he took off in a nice steady walk, but he had a head start at 60 meters, and he walked at a constant speed of 3 meters per second. So as you're looking at the turtle, you can see that his speed is constant, and that he started at 60 meters, and it just increases 3 each time. So this in my mind, because it's a constant speed, is a linear function. And he also crosses the finish line between 13 and 14 seconds. And then finally, the most challenging one, the alligator. He just sat there for 5 seconds, and I took this to mean that he did not move for 5 seconds, and then after 5 seconds he started moving. So he began at a pace of 1.5 meters per second, and then he sped up going by a factor of 1.5 times. So his is a little more complicated. You'll see right here for the first 5 seconds, no speed, no distance. And then the next, once he starts moving, that next second, he moved at a speed of 1.5 meters per second. So that's how far he went. He went 1.5 meters in that second. And then by a factor of 1.5, which means 1.5 times 1.5. So that's how far he went in the next second. And if you add that back to the 1.5 he had already gone, you get 3.75. And then the next second, he went another factor of 1.5, so we're at 1.5 cubed, and you add that to how far he had previously gone, and you get that he has now gone 7.125 meters. You can see the pattern, and I tried to color code it to kind of notice that you were adding on to these previous terms. And conveniently, he also crosses the finish line between 13 and 14 seconds. So next I thought I'd look at a graph and see if I could discern anything from it. So I went to Desmos and put in the formulas, and you can see this is my finish line, 100 meters, and you can see in red is the turtle plowing along with his linear function, and he's hitting somewhere in here. And this green is the rabbit with his quadratic, and he's also hitting somewhere in here. And the black looks to me to be an exponential, and he's also hitting somewhere in here. But I was actually really struggling to find, it was so close to find exactly where he hit. So then I went to paper and pencil. And so the first one I looked at was the turtle, because he was a little bit easier being linear. He had his beginning distance was 60, and his speed was 3 constant speed. So I wrote the equation d equals 60 plus 3t, plugged in 100 for the distance, and found that he crossed the finish line after 13.333 seconds. Next, I looked at the rabbit, and I actually struggled to find a quadratic equation for him. So I put my information into the calculator under Stat Edit and found the quadratic, and it was a perfect quadratic formula. And it was 1/2 t squared plus 1/2 t. I also put in 100 for d and solved, and got that he crossed the finish line after 13.651 seconds. So he's actually slower. Well, not slower than the turtle, but he crossed after the turtle. And then I really struggled with an equation for the alligator, so I actually wrote a recursive equation. here it says to get the next term, you take the previous and you add this speed, which is 1.5 to however many factors you are. So after the first second, it's only 1.5 to the first. And after the second, it's 1.5 to the second, except for it doesn't start until 5 seconds. So hence this part. So as you're looking, you'll see that at 13 seconds, he was at 73.887, and at 14, he was at 112.330. So I know it's somewhere in between, so I really just started doing guess and check. And I kept plugging in numbers between 8 and 9 for the exponent until I got as close to 100 meters as possible. And I got that happened at 8.0462. And when you consider this, that you have subtracted 5 to get that exponent, you figure out that the alligator crosses after 13.0462 seconds and is therefore the winner.